Hello, everybody. Today we're going to be looking at lesson 7.3, and that is angle-angle similarity. So what that states is if two angles of one triangle are congruent or the same as two angles of another triangle, then those two triangles are similar. So for example, I have a triangle here. It's got 45 degrees, 100 degrees, and we don't know that. That's A, unknown. And then I have another triangle that has 45 degrees, so that angle's the same. And then 100 degrees. So we know two of those angles are congruent, and we have an unknown. These two triangles are congruent, and if we look at this, we've got 100 plus 45 plus this A is going to equal to 180, and 100 plus 45 plus B is going to equal to 180, which means those are going to have the same measures. So those two triangles are similar. Now, looking at this next pair here, I have 70 degrees, 58 degrees, 70 degrees, 49 degrees, which means angles C and D are not going to be the same. And they'll both add up to 180 degrees still. The triangles are not congruent though. So those are not similar. All right, when we have similar triangles, what we can do is we can use what we know to find missing measurements. So what I've done here is, here's my triangle. I've got this large triangle and then a smaller triangle within that. When you see a triangle within a larger triangle, those are going to be similar. All right, and that kind of goes along with slope, if you remember talking about the slope when we're doing this. Then I broke it apart. I drew that large triangle here, and then I took the small piece and I drew it right here. And I labeled my heights that I know and I don't know. So on this small triangle, I knew 2 meters and 10 meters, so I've got 2 and 10. And on the larger triangle, I have 18 for the length, and I don't know the height, so that's just H. So I have, this is one way to set this up, AB over CD, so we can do that, big over small is equal to big over small, so BE over DE. And I guess I could put another L on my small. All right, once I have my side lengths, I can substitute my values. So I have H over 2, so H over 2, big over little, is equal to 18 over 10, 18 over 10. So then I'm just going to cross multiply, and I have 2 times 18 and 10 times H. 2 times 18 is 36, so I have 10H equals 36. Solve for H, divide by 10, bring down my H. 36 divided by 10 is 3.6. So that height of AB is 3.6 meters. All right, now we're going to go over some of these for practice. Number 1 says, explain whether the triangles are similar. Label the angle measures in the figure. So triangle ABC, that's here, has measures 41 degrees, 30 degrees, and then all we need to do is take 180 and subtract 41 and 30, and then we get that third measurement is 109 degrees. 109 degrees. All right. Triangle DEF, so that's DEF right here, has angle measures 109, 30 degrees, and again, I would subtract, but I should already see 109 and 30, so I should know that that third one is going to be 41 degrees. But if you want to subtract from 180, you can. All right, because two angles in one of the triangles are congruent to two angles in the other triangle, the triangles are similar. So that one is similar. Number 2, a flagpole casts a shadow 23.5 feet long. At the same time of day, Mrs. Gilbert, who is 5.5 feet tall, 5.5 feet, or 5.5 feet tall, casts a shadow that is 7.5 feet long. So this is Mrs. Gilbert, and she's 5.5 feet tall, and there's her shadow of 7.5 feet. And we know that the flagpole's shadow is 16 plus 7.5 at the 23.5. So this right here is 23.5 feet for the overall. How tall in feet is the flagpole? Round your answer to the nearest tenth. So I want you to notice they set this up a little bit differently. They put height is equal to height, right? small height, large height. So we're going to go small base length, so 7.5. And then the longer base length is 23.5. 23.5. You would cross multiply and divide. So 23.5 times 5.5 is 129.25 is equal to 7.5h. Divide by 7.5. Divide by 7.5. 7.5 divided by 7.5 is 1. I bring down my h. And then when I divide 129.25 by 7.5, it's going to give me a repeating decimal, but I'm just going to round to the nearest tenths. So what you're going to end up with is 17.23 repeating, but I'm just going to put 17.2 feet. I'm rounding to that nearest tenth. All right, number 5. Rosie is building a wheelchair ramp that is 24 feet long and 2 feet high. She needs to install a vertical support piece 8 feet from the end of the ramp. What is the length of the support piece in inches? So that's this piece right here we don't know the height of, right? So here's our support 8 feet from that end. All right, so we're going to set up a proportion here. And I'm going to use, let's see, I'll set it up like they did here, where we do the height and the height. So 2 equals h. And I use this longer one, so that's going to be 24 over 8. Okay, from there we're going to cross multiply. 2 times 8 is 16, 24h. All right, then we just divide by 24, divide by 24. All right, I'm going to simplify this. 16 over 24 simplifies to 2/3. And the reason I'm doing this is because it's in inches. So you could have either converted all of this to inches, but you'd be dealing with some larger numbers, or just know that this is feet and 2/3, and we got to figure out how many inches are in 1 foot, and that's 12. So 2/3 of 12 inches will give me my inches. 2 times 12 is 24. And 3 times 1 is 3. 24 divided by 3 is 8. So 8 inches. All right. Number 6, the lower cable meets the tree at a height of 6 feet. So right here, I have a height of 6 feet. And extends out 16 feet. So this right here is going to give me 16 feet from the base of the tree. If the triangles are similar, how tall is the tree? So we are looking for the height of the tree, some unknown. All right, so let's set up a proportion. And let's see, which way do I want to go? Why don't we do h is equal to 6. So h, this is big and this is little. And so 56 over little is 16. So here's my heights over my lengths. We're going to cross multiply. So I'm going to have 16h is equal to 56 times 6 is 336. Divide by 16, divide by 16. H equals 21. So the height of the tree is 21 feet. All right, I've got another one here for you. And I want you to try these on your own. So take a minute. So we've got 4 different triangles up here. It wants you to find the missing angle measures. So we've got a missing one here, 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 and here. Those are missing angle measures. So you need to find the measure of angle B, the measure of angle F, the measure of angle H, and the measure of angle K. So find those. From there, I want you to tell me which triangles are similar. And then I want you to determine which angles are congruent to the angles in ABC. So ABC, when you know which triangle is similar, then I want you to determine Angle A is congruent to which angle? All right, so hopefully you've gotten that. This first part, all this requires you to do is to subtract these second angles from 180 to determine the angle measure of B. So angle B is equal to 42 degrees. So that's 42 degrees. Angle F, when I subtract 64 and 47 from 180, I'm going to get 69 degrees. And then the measure of angle H is equal to 64 degrees. And the measure of angle K is 53 degrees. All right, now I can go through here and determine which of these are similar. So I've got 47, 69, 64. Well, that's right here. These two are similar. And then I have 85, 53, 42, 85, 53, 42. So triangle ABC and triangle JKL are similar, and triangle DEF and triangle GH, well, we'll go GHI are similar. Yeah. Now looking at our angles here for triangle ABC. So A is 85. So I'm looking for the 85 right here. So we've got angle J is congruent to angle A. All right, now let's look at the next one. I've got angle B is 42. So then over here, angle L is congruent to angle B. And then the last one that leaves, angle K at 53 is congruent to angle C, which is also 53 degrees. All right, hopefully you did really well on those. If you have any questions on any of this, please come to a meeting, send me an email, and have a great day.